Right. Okay, children, as usual, today we meet our grade 10 class, right? I think you may got the tute, so you may have already get the tutes there. Tute ka hambela thi hamotama, right? Because one student is he didn't get my link there, right? So I just provide him the link. Wait. Right. If you can hear my voice, you can see me, right? So just send me the message. Message එකක් දාන්න පොඩ්ඩක් I can hear very much. You just send me, you can listen me, you can hear my voice, just send me the message. Okay. Okay, Shalomi. All right. All right. Thank you. If you can, now you can hear my voice. You can listen to, can engage in the learning process, right? Okay. Okay. Without wasting our time, let's start our teaching process, right? I think you may have already got the tutes. Amount of tute එක හම්බුණා නේද පුතේ ඔයගොල්ලෝ ඔක්කොටම? Tute එක හම්බුණා නේද? Yes. I have already send you the tutes there. මම හිතන්නේ හැමෝම tute එක අරගෙන දැන් ඉගෙන ගන්න ලෑස්ති වෙලා ඇති. අපි එහෙනම් අපේ වැඩි පටන් ගමු පුතා, right? Today our topic, I think you may have got the tute. හැමෝම දැන් tute එක තමන්ගේ අතට ගන්න. ඊට පස්සේ අපි ඉගෙන ගන්න වැඩේ ලෑස්ති, right? Our topic ඒ වගේම මේ from this lesson you can watch YouTube as well. මේක YouTube එකේත් බලන්න පුළුවන් ඔයගලන්ට, right? අපි එහෙනම් පටන් ගමු පුතා අපේ lesson එක, turning effect of a force. Turning effect of a force. That is our unit. Turning effect of a force, right? So before starting my unit, I'm going to ask you few questions there, right? ඔයගොල්ලෝ හැමෝම මේ questions වලට උත්තර දෙන්න ඕනේ. There are so many methods to answer my questions. You can using chat, you can send me your answers, as well as you can switch on your microphone and you can talk with me. Yeah. When you switch on your microphones, please be careful not to disturb for our live sessions, right? Okay. Now, so you may have tute ගන්න පුතා, tute එක අරගෙන මොන්න බලන්න. First, all right. Okay. Wait, I just all right. I'm going to share my screen, right? Okay, right. You can see my screen now, right? Look at this. Our topic, grade 10, unit number 11. What you call? Turning effect of force. Now you can see the diagram here. දැන් ඔයගොල්ලන්ට හැමෝටම පේනවා පුතේ diagram එකක් මෙතන තියෙනවා. Right? So my question, this is my question there. Right? This is my question. Now there are some points here. A point, B, C, D, like there are some points there. And you can see the hinge here, right? Now what you are going to do, we are going to open this door. Assuming that you are going to open this door there, right? Now my question, at which point out of this A, B, C, D, at which point was it, we required lowest force to rotate the door. I mean, out of A, B, C, D points, which point we need lowest force to move this door, right? Some students just now they coming and they ask me, right? Wait, Putha, product, you just think about the answer. At which point was the force required to rotate the door? Minimum, right? Minimum force required at which point? You can send me your answers, Putha. Some students they are sending answers using WhatsApp. Yes, Shalomi. All right. So others you can send your. You can use the chat options, right? Okay, right. So a lot of answers are flowing. Yes, that's correct. We need lowest force to move this door using point A. Yes, point A is the that one, right? Next, out of these 4 points, which points need maximum force to what you call rotate? Maximum force needed from which point? Okay, answers are flowing. Right, we'll see what's the correct answer. Yes, very good, Putha. Your correct answer. Yes, point D. Right, point D. Now it's very clear that some students answer for that question. Point D. Very good. Right. Now take your tute. You have given a similar diagram on your tute and ask. Just complete the tute now, Putha. At which point was the force required to rotate the door maximum is the point D point. Mark the point D. Point D is the correct answer. And at which point was the force required to rotate the door minimum is point A, right? Point D and point A. Now, so now we'll go for the next part of the our lesson, right? Okay. Now it's very practical thing, practicable thing. When you opening or closing door, so you can when you're using point A, it is very much convenience, right? Door open close right? But if you try to do this one using point D, it's very difficult task. Now you may have a question about why something like this. Today we are going to learn how this happens. Right. Now, what I'm going to do, right? You just think about this as a door, right? So if you use from this point, it is easy to open or close the door. From this point, it's very difficult to open or close the door, right? From your tube, point A, we require very low force, right? Using lower force, you can move this one. From this point, you need a higher force to move this one, right? Force right? Now, something is there, right? Something is there. I'm going to tell you how these two things happens there, right? There is a relationship between force and this distance. Okay. Now, Putha, this is the force you applied, right? And this one, right? We are going to go for the presentation again. Presentation. If you have questions, you can ask me. Any questions you can ask me. But wait, I'm explaining these things there, right? All right. Now you can see there. We'll go for the presentation. So there is a straight line. You can see there is a straight line. This straight line we called as the axis of rotation. What we call this one, Puta? This is we called as the axis of rotation. Now, if you think about this one as a door, this is the axis of rotation. Make a axis of rotation. Did you understand? Right. Make a door move around the axis of rotations. This straight line, actually, there is no physical line here, but we assume that there's a hypothetical line that is be called as the axis of rotations. This door move around the axis of rotations. Make axis of rotation. Next question. If you are applying the force very much close to the axis of rotation or far from the axis of rotation, out of these two options, which one? It's very easy to open or close the door. Very much close to the axis of rotation, or very much far from the axis of rotations. What are the answers? Right. Okay, Manisha. Right. Lisa, right? Okay, Anita, answer 7. Right, I'm just checking your answers. Right. Okay, sorry. Right, very good. Nisal, right. Okay, I can see your answers. Right, very good. Shalomi, Tarindi, yes, Tarinda, yes, it's very good. Lizara, close to the axis of rotation or far from? Lizara, close to the axis of rotation. It's very easy to open this one close to the axis of rotation or far from the axis of rotation. Yes, right. Okay. Right. She's telling that it's very easy to open this one close to the axis of rotation. So okay, that's the idea. No? But yes, by practically, if you try to open this door far from the axis of rotations, it's very easy to move this one, right? That's why door locks are fixed somewhat far from the axis of rotations. So otherwise we can fix the door lock from here, no? So assuming that now we don't fix the door locks on the point D. We fix the door lock on the point A. Why? Because when the distance from the axis of rotation is increasing, it's very easy to move this one. Right. Now, that right. Now just take your tube and complete this one. Complete. Here the door rotates around the axis passing through the hinge as shown in the figure. This axis is known as, what is the name given for this axis? What is the name given for this axis? Puta, tell me what is the name given for axis? Yes, what we call this one? Axis of rotation. Message axis of rotations, right? Complete the blanks on your tube, Puta. This is called as axis of rotation. Axis of rotation. Axis of rotations. Complete the blank. Axis of rotation. Right. So the door move around the axis of rotation. That is okay. Right. Then the product. Now we are going to study the relationship between, some kind of a relationship between two main components. Relationship. Now we are going to discuss about the relationship between the two main things. Right. Now look at this one. This is the force that we apply. I mean, this is the point where you apply the force, right? It could be A, B. I told you there, from the A point, it's easy to move this one, right? And there is a relationship in science. The force should be multiplied by the perpendicular distance. What's the perpendicular distance? It's very important to get some idea about these terms there, right? Perpendicular distance. Well, look at the perpendicular distance. Perpendicular distance from the rotational axis to the line of force of action. Yes. Now, just think about the door is moving like this, right? Door is moving like this. Then, this is the point where you apply the force. And the force you applied now, what is the unit of the force? The chat message unit of the force. Hurry up. Unit of the force. What is the unit of the force, Putta? I'm checking. Right, very good. The answers. Right. Yes, unit of the force is what? Right. Very good. Right. Amisha, Nisal, Manisha. Right. Yes. Unit of the force is Newton. Very good. Unit of the force is Newton. And this is we are going to learn about we are going to study about the moment of force now. Moment of force means actually the force that you apply. Unit of the force is Newton. Force that you apply, force should be multiplied by perpendicular distance. Perpendicular. What do you mean perpendicular? Perpendicular. Now, right. This is the force, because now when you apply the force, this is the axis of rotation. This is how you apply the force. Perpendicular distance from rotational axis to the line of action, right? If you apply some kind of a point, the straight line you draw for the place where you apply the force, we call it as a line of action. Say, for example, now assuming that this is, if you think about 3D way, right? Now this is the axis of rotations. Now you apply the force from here. The straight line, this is point of application, means the place where you apply the force. And if you draw the straight line for the point of applications, this is called as the line of action. Now, just think about, now you apply force from here, line of action. This is the line of action. Line of action, right? Like that way, this is the point of application, line of action, right? Then, perpendicular distance. Why we call it as a perpendicular? So if you think about now in the mathematics, you may have learned about the perpendicular. Perpendicular means if the straight plane is there, now 90 degree straight, no? Yeah. So this is called as a perpendicular. Like that way, this is the line of actions. If you draw a 90 degree line, so this is the perpendicular. Right. You can see the perpendicular. Now, this is the line of action. This distance is perpendicular to the line of actions. Okay, Buddha? Right. Perpendicular distance from rotational axis, otherwise axis of rotation, to the line of actions. Perpendicular distance from axis of rotation to the line of actions. Now you see there, you are going to open the door, right? This is the line of action. This is the axis of rotation. Perpendicular distance from rotational axis to the line of action of the force. That is we called as the moment of force. Just I'm going to write this one. පොඩක් අපි definition එක මම ලියලා ඉන්න පුතේ. ඒක ඔන්න බලාගන්න. Perpendicular distance from the perpendicular distance from the rotational axis to the line of force of action, to the line of force of action, right? This is we called as the moment of force, right? Actually, moment of force means some kind of possibility to move. Yeah. So there is another name for this one, turning effect. Possibility to turning something. That is we call as a turning effect, right? Again, just go through the tube. Just go through the tube there, right? Here the door rotates. Slides right? Okay. Here the door rotates around axis, passing through the hinge as shown in the figure. This axis is known as, complete your blanks, complete the blanks. This is called as the axis of rotation. What do you call this one there? This is axis of rotation. This is the axis of rotation. Okay, axis of rotation. Axis of rotation. If you have questions, anything, send me. You can send your questions different methods. You can use chat using Zoom live discussion, as well as you can WhatsApp my number, because when I'm teaching you, I just check your WhatsApp messages as well as you can switch on your microphone and you can ask the questions. So many methods to access me there, right? Okay, axis of rotation of the door, right? Okay, did you complete the blanks? Blank complete nothing. Then next one, the product of the force and perpendicular distance to the line of action of the force from the axis of rotations, right? This is the product. Product means, you know, the multiplication method, you know that. Product force and perpendicular distance from the rotational axis to the line of force of action. So otherwise line of action of the force we called as the moment of force. So if sometime in your question paper, in your past papers, you have to find the moment of force. So what you have to do there, how to find the moment of force, you have to multiply the what you call force and multiply. This is, you have to find the line of action. So this is the line of action, and find the perpendicular distance to the line of action to the axis of rotation. Axis of rotation again the line of action perpendicular distance multiplied with the force, you can calculate the moment of force. This is the way to calculate the moment of force, right? Definition එක පොඩ්ඩක් ලියව right අපි මේක බලමු පුතා. So complete the blanks. The product of perpendicular distance to the line of action of the force from the axis of rotation is known as moment of force. Okay. Now there is another part given in the tube there. Tube එකේ පොඩ්ඩක් කොටසක් තියෙනවා. This tendency for rotation due to the action of force is known as turning effect of the force. Tendency for rotations. Tendency again yes. Tendency for rotations due to the action of force. force is known as the turning effect of the force. Yes, turning effect. Just highlight karaganda putaya sentence එක. Sometime you may ask the what you call turning effects means there. The tendency for rotations, the tendency for rotation due to action of a force is known as the turning effect of force. Highlight this sentence. The tendency for rotation due to the action of a force is known as turning effect of force. Right. Turning effect of force. All right. That is called as a turning effect of force. Right. Then, wait. Now, you can see there how to find the moment of force. Right. How to find the moment due to force, not the moment of a force. Both terms are used in your syllabus. Moment due to a force or moment of a force, right? Now, moment due to a force is known as, is equal to the force multiplied by perpendicular distance from the rotational axis to the line of force of actions. Otherwise, yes. Force be measured using Newton and what you call distance be measured using meters. So how to get the moment of force, moment due to a force, final unit එක මට පොඩ්ඩක් මෙතන ඔයගොල්ලෝ you have to send me ඔයගොල්ලෝ WhatsApp වලින් හරි chat එකෙන් හරි මට message කරන්න ඕනේ මොකක්ද moment due to a force. එතකොට force multiplied by perpendicular from the axis of rotation to the line of action of force, no? Final unit of the moment due to force. Second one, message. Okay. Right. Okay. Right. Now you got some idea about how to find the moment due to a force. What you have to do? Force multiplied by perpendicular distance from the rotational axis to the line of force of actions. This is the way to find. Very good, Puta. ඔයගොල්ලන්ගේ answers උත් එනවා මම චුට්ටක් බලනවා. Right. This is the way. Yes, very good. The answer is actually yes, as you told there, Newton meter, because here Newton meters. Newton meter is the unit that we use to find the moment of a force, moment due to a force. ඒක අපි හොයන්නේ Newton meters. We find the what we call force using moment, but Newton meters. So Nm is the unit there, right? Is there any questions, any problems related to the perpendicular distance, axis of rotation, line of actions? Ask me if I need to explain any of these terms, because these three terms are important.
Excuse me, sir.
Yes, ask me.
Sir, what should you want to write on the highlighted box?
You have to write. Wait, Puta, thank you for your questions. You have to write down this equation. You have to write down this equations. Moment due to a force is equal force multiplied by perpendicular distance from the rotational axis to the line of force of actions. Write down this equation. if you have finished writing this equation, send me the message එකක් දාන්න. I have finished කියලා. Then I can go for the next part. There are some blanks given on your tute. Tute එකේ පොඩි blanks වගේක් දීලා තියෙනවා. අපි ඒක ඊළඟට මම කියන්නම්. Right? And if you have finished writing the equations, just send me a message. Message එකක් දාන්න. Right, good. Okay, Manisha, okay, Elizara, right. Right. Good. Now, if you have some questions related to the, so you must confident about these terms there. Check whether you are confident about these terms. What are the terms? Perpendicular distance. Perpendicular distance. And line of action. Line of action. And perpendicular distance, line of action, and axis of rotation. Because these three terms are very important for this unit. The unit again, terms what you call turning effect of a foreskin. What you call perpendicular distance, line of action, axis of rotation. Perpendicular distance out. This is the line of action. The line that you exert the force, we call as the line of actions. From the axis, it's a perpendicular distance. This is the line of action. For the line of action, you measure the perpendicular distance. And this one is the axis of rotations. There is no physical axis of rotation. You can't observe any kind of axis of rotations. It's a hypothetical line that we draw. We call that as the axis of rotation. Axis of rotation. Is there any questions you can ask me? You can ask any questions. Right. Seems that you don't have questions, right? Now, another thing, you send me what they call multiple choice question paper. So yesterday it's a bit busy for me there. Most probably tomorrow is my holiday there. So I can correct your papers and I can send you back tomorrow, right? Because tomorrow I don't have any school. I stay in home there tomorrow because the school, they have allocated certain days to attend there. So therefore, tomorrow is a holiday for us there, right? So then I can correct your second, because first assessment that questions I gave you, I have already corrected and send you there. The questions ටික ඔක්කොම බලලා first assessment එකේ marks දාලා ඔයගලන්ට ඒවල අරක ඒවලා තියෙනවා assignment එකේ. ඊට පස්සේ තව assignment එකක් ඒව multiple choice question assignment එකක්. ඒ assignment එකේ බලලා මම මේකත් හෙට ඔයගලන්ට එවන්න පුළුවන් try එකක් දෙන්න, right? Tomorrow is free day for me, because, right? So then the moment due to a force is a kind of a what you call rotation of there, right? So it's a rotation there. Moment of a force, it's a kind of a rotation. So the moment is a tendency for rotation. Tendency rotation. Moment due to a force means tendency rotation. This rotation could be clockwise or anti-clockwise. You observe. Now this is clockwise or anti-clockwise, right? Now you have given on your tube some space, blanks are given. ඒකේ පොඩ්ඩක් ලියා ගන්න. The unit of moment of a force is Newton meters. The unit of moment of a force is Newton meters. The unit of moment of force is Newton meters. Newton meters. Since the moment is tendency for rotation depending on whether the rotation is clockwise or anti-clockwise, the moment two has to be clockwise or anti-clockwise. The moment two has to be clockwise or anti-clockwise. Because moment of force also, you can think about clockwise moment of force and anti-clockwise moment of force. Yes. Now, and then you just observe them. මේ කියන question එකට ඔයගොල්ලෝ answer එක එවන්න ඕනේ, right? හරි. දැන් මෙන්න මෙහෙම එකක් තියෙනවා. Right. This is the door. මේ door එක මෙහෙම තියෙන ඔයගොල්ලන්ට පේනවා, right? This kind of motions මෙහෙම move වෙනවා. This is now you just apply force from these positions and you just move like this. Move කරනවා. එතකොට this one, now this is the way original positions, you just move the door like this. Move karna. This is clockwise. Right. Okay, Johan asking to tell the question again. Yeah, right. Okay, now this is the door, you can see there, right? No problem, right? If you move the door like this, this moment of force is, you can calculate the moment of force, no? Force multiplied by perpendicular distance from the line of action to the axis of rotation. This movement is clockwise or anti-clockwise? That's my question. Right. Okay. Send me your answers, right? Okay, Nizal, Manisha. Okay, answers in our Kodak. Right. Good. Right. Still, I couldn't find any incorrect answers. Nice, very good. Yes. Actually, that is anti-clockwise motion. It's anti-clockwise motion. Anti-clockwise momentum, right? So moment of force also has a anti-clockwise or clockwise. Yeah. So we have to discuss these things later on. We'll go for the next part. Now you are confident about the perpendicular distance, line of action, axis of rotations, how to find the moment due to force or moment of a force, how to find their moment due to a force, how to find force Newton multiplied by perpendicular distance from rotational axis to the line of action of the force, the line of force of actions. Perpendicular distance from rotational axis to the line of action of the force or line තේරුණා නම් ඒකේ force කියලා අපි එතකොට ඊළඟ කොටසට move වෙමු right because tute එකේ දැන් අපි first page එකේ still we have discussed some other parts also ඒ ටිකට අපි දැන් යන්න ඕනේ ක්‍රමක්‍රමයෙන් next year we discuss some activities there understood කියලා message එකක් දාන්න අපි එතකොට යන් ඊළඟ කොටස right okay පුතා okay right okay මම මේක පොඩ්ඩක් මම හිතන්නේ මේ bandwidth එක චුට්ටක් අඩු කරන්න මට just give me 1 minute ඈ පොඩ්ඩක් විනාඩියක් දෙන්න all right because there is a live streaming there ඒ live streaming එකේ හින්දා තමයි bandwidth එක අඩු වෙලා තියෙන්නේ මම ඒක නවත්තන්න